Welcome to the deep dive. Today we're jumping straight into something pretty huge. A massive strategic plan, really, that's looking to reshape, well, the very foundations of global power.
That's right.
For, the last 100 years or so, geopolitical strength, national sovereignty, it was all tied up with getting access to cheap, plentiful energy. Oil, basically.
Oil was king.
Exactly. But what if that's changed? What if the key strategic resource for this century isn't oil anymore? What if it's compute power?
And that, right there, is the central idea we're digging into today.
Yeah.
Based on the sources we've reviewed, the concept is compute is the new oil.
Compute is the new oil. It's catchy, but it sounds like it's much more than just a slogan.
Oh, absolutely. It signifies a really profound strategic pivot. We're talking about the infrastructure that defines national sovereignty in the 21st century. Things like data, raw compute power, access to sophisticated AI. These are now arguably replacing the energy resources that propped up the empires of the 20th century.
And this isn't just some abstract theory floating around, especially not in India. We're looking at a very deliberate, proactive strategy, a nation-building kind of move, wouldn't you say?
Definitely. It positions the country right at this crucial intersection, the meeting point of clean energy and artificial intelligence. The sources we're looking at argue that these two forces, especially when fused together, are going to be the defining elements of power for, well, maybe the next 50 years or more.
So the mission, as laid out, is what? India needs to move beyond just using digital stuff developed elsewhere.
Precisely. The strategic objective is quite clear. India can't just remain a consumer of global digital services. The goal is to transform into a global digital producer-exporter. That means securing self-reliance, sovereignty, and frankly, significant economic leverage on the world stage.
And that kind of transformation doesn't happen without serious investment in your own capabilities, your own infrastructure.
Exactly. Sovereign infrastructure is key. Which brings us to the most concrete, sort of headline-grabbing piece of this whole vision.
Right, the part that puts actual money and action behind the concept.
Yes, a huge U.S. $15 billion strategic partnership. This deal involves the Adani Group and Google, LLC.
$15 billion. That's substantial.
It is, and the purpose is very specific.
Yeah.
To build India's single largest AI and data center hub.
Okay. And where is this happening? You mentioned the intersection of AI and clean energy.
It's happening in Visakhapatnam, often called Vizag, in the state of Andhra Pradesh. You can really think of it as the place where silicon, computing power meets the sun, clean energy.
Vizag. Okay. So to really understand the significance of this $15 billion project, we need to grasp that it's not just another big data center popping up, right?
Not at all.
Right.
It's being framed quite deliberately as a fundamental shift in what constitutes national infrastructure. Think about it like this. For decades, national security planners focused on physical assets, ports for trade, railways for transport, power grids for energy.
The traditional pillars.
Exactly. Now, things like raw compute power, massive data centers, and sophisticated AI capabilities are being added to that list. They're not just commercial nice-to-haves. They're seen as essential national security assets in the digital age.
The analogy to oil really works here then, because oil wasn't just about finding it. You needed this huge, vertically integrated system exploration, drilling, pipelines, refineries.
Precisely. And compute needs something similar. You need the data pipelines, that's your fiber optic cables, you need the processing capacity, your data centers, and critically, you need enormous amounts of power to run it all reliably.
Which loops back to the location choice.
Right.
Why Vizag? You said its geography is destiny. That sounds significant.
It really is. The sources emphasize that Vizag wasn't picked randomly from a map. Its specific location offers a critical combination of advantages.
Okay, so before we even get to the green energy part, let's unpack the technical reasons. Why Vizag for this massive AI hub? What makes it this future portal city you mentioned?
It boils down to two main things initially: connectivity and energy potential. Let's start with connectivity. Vizag is already a major natural deep-water port, which is important for traditional industry.
Right.
But in the context of AI and data, its underwater geography is arguably even more valuable. It's already a major landing point for several crucial high-capacity subsea fiber optic cables that run across the Bay of Bengal.
Okay, let's pause there for a second. For you listening, maybe you don't think about undersea cables much, but they're basically the hidden backbone of the entire internet. These massive bundles of fiber optics lying on the ocean floor, connecting continents. So why is being a landfall point so critical for an AI hub?
It's all about latency, speed, In the age of AI, especially for real-time processing or connecting to global markets, minimizing the physical distance data has to travel is paramount.
Hmm.
By building the data center right where these massive international data pipes come ashore.
You cut down the travel time for the data signals.
Exactly. You minimize latency to key markets, particularly in Southeast Asia and potentially beyond. This effectively transforms Visag from just a port handling physical goods into what the sources call a port of immaterials.
A port of immaterials. I like that. So the main cargo becomes data measured in terabits per second, not tons of steel or coal.
Precisely. It becomes a strategic gateway for rapid global data exchange, which is absolutely essential if you want to be a major player in the global AI economy.
That makes a lot of sense. It paints a picture of this city really evolving, moving from that 20th century identity based on heavy industry steel, coal, oil refining, to a 21st century hub focused on processing and moving data packets. That feels like a huge, almost symbolic industrial transformation.
It is, and it's described very deliberately in the source material as a shift from atoms to bits, from smoke to light. You're essentially digitizing the city's industrial footprint.
Is there a local angle to this too? Does it help the existing workforce?
That seems to be part of the thinking. This transition is framed as crucial for ensuring local economic stability and evolution. Instead of just importing completely new tech and foreign talent, the idea is potentially to retool some of the existing energy sector expertise, the engineering skills, for managing these massive server farms, the associated cooling systems, the large-scale battery storage that's needed. It's about adapting the existing industrial base.
Okay, that brings us to the scale issue. You mentioned this earlier, and it sounds like a major hurdle. We're not just talking about a few server racks. The plan is for infrastructure capable of supporting gigawatt-scale AI workloads.
Yes, gigawatt scale.
What does that actually mean in practical terms? Why is that specific scale such a monumental infrastructure challenge right out of the gate?
Well, to put it in perspective, a single gigawatt, that's 1 billion watts, is roughly the peak electricity demand of a medium-sized city. Or it's the output of a very large traditional power plant, like a nuclear reactor or a major coal-fired plant.
Wow.
So powering an AI hub at that scale, especially when running these huge, energy-hungry language models that need continuous training, running complex simulations, it requires not just an enormous volume of electricity, but absolutely stable, reliable power. 24 hours a day, 7 days a week, 365 days a year, no fluctuations, no brownouts.
Because a dip in power could ruin incredibly complex calculations, waste huge amounts of processing time and energy.
Exactly. It could be catastrophic for the computations. And this leads directly to what the sources identify as probably the single biggest immediate risk: infrastructure lag.
Infrastructure lag, meaning the demand for power from the AI hub arrives instantly, but building the power plants and transmission lines to supply that power takes years.
Precisely. If the compute capacity gets built, but the grid upgrades, the new generation capacity, the high-voltage transmission lines haven't kept pace, the whole multi-billion-dollar project could effectively stall before it even gets going properly.
So what do the sources say needs to happen to avoid this? How does India need to prioritize its infrastructure build-out?
They really emphasize a layered, concurrent approach. You can't build the data centers and then think about the power. Layer one is the power grid itself. It needs to be modernized, digitized, made much more resilient, and crucially, capable of handling the two-way power flow that comes with integrating large amounts of renewables.
Okay, grid first. What's layer two?
Layer two is the transmission system. You need massive, high-capacity transmission corridors. Think ultra-high voltage lines capable of carrying potentially gigawatts of power from where it's generated, maybe remote solar fields or coastal wind farms, directly to the Visag hub with minimal loss. These have to be planned and built simultaneously with the data centers.
So power and connectivity infrastructure have to lead the charge. If they lag, the whole thing grinds to a halt, no matter how much silicon you've installed or how much talent you have.
That's the core challenge. Which brings us back to Visag's second major geographical advantage: its energy potential.
Right. You mentioned it sits near coastal wind corridors and inland solar belts. How is that specific geography being leveraged to provide the kind of ultra-reliable gigawatt-scale power these AI data centers demand?
The key strategy here is aggressive solar hybridization. Data centers, as we said, need power 247. Solar power is great, but the sun goes down. Wind is great, but it's not always windy. You can't just pause a massive AI model training session when a cloud passes over.
So hybridization means blending different sources.
Exactly. It means combining large-scale solar power generation with other complementary and ideally highly stable renewable sources. In Visakh's case, that points strongly towards leveraging the consistent coastal wind resources and potentially looking further ahead using some of that renewable power to produce green hydrogen, which can then be used for power generation when solar and wind aren't available.
And you need something to smooth out the gaps, right?
Absolutely. This blended generation needs to be backed up by massive local battery storage systems. Huge banks of batteries located right near the data centers, capable of absorbing excess power when generation is high, and instantly discharging power to maintain supply when generation dips. This combination of hybridized renewables plus large-scale storage is what aims to deliver that resilient, round-the-clock power supply needed to keep the AI hub running without interruption.
So this idea of Vizag becoming the green Silicon Valley of the East, it's not just marketing fluff. It's actually a technical requirement driven by the need to minimize energy costs in the long run and guarantee that critical operational stability.
Precisely. It's designed as a prototype where the physical energy infrastructure and the digital compute infrastructure are intrinsically linked, almost co-located.
Why is co-location so important?
Well, primarily to minimize transmission losses. Moving electricity over long distances results in energy loss. By generating the power, storing it, and consuming it in the data centers, all in close proximity, you maximize efficiency. This creates a very specific, localized competitive advantage, especially if the renewable energy costs are low.
Okay, this synergy between the energy and the compute seems to be the real core of the long-term vision. Let's dig into that.
This is where it gets really interesting strategy-wise. It's about deliberately converging two massive technological revolutions that are happening simultaneously.
Which are?
First, the AI revolution itself, which is seen as collapsing the cost of intelligence, making sophisticated prediction and automation much cheaper. Second, the clean energy revolution, which is dramatically collapsing the cost of generating power, especially from solar and wind.
And the argument is, when you combine those two trends, when the marginal cost of both intelligence and energy starts heading towards zero, you unlock the potential for exponential economic growth and societal transformation.
That's the core engine they're trying to build, this virtuous circle between AI and clean power. India seems to recognize that if the future of compute, especially energy-intensive AI, is powered by cheap, domestically produced, renewable energy,
then it gains a huge, sustainable long-term economic advantage over competitors who are still stuck using expensive, perhaps imported fossil fuels, or who face higher renewable costs.
Exactly. And that economic advantage is immediately tied to an ethical and strategic one.
How so?
Because, as you know, there's growing global scrutiny over the massive carbon footprint associated with training these enormous AI models. It takes staggering amounts of energy. So, by committing to power its AI infrastructure with clean energy from day one,
India can position itself differently as the global low-carbon AI factory, perhaps.
that's precisely the framing used in the sources. The goal is that every computation, every petabyte of data processed in this new Visag hub is intended to be, in effect, a carbon-neutral act of intelligence.
Which plays very well with international investors and corporations who are increasingly focused on ESG criteria, right? Environmental, social, and governance factors.
Absolutely critical. For our listeners, ESG criteria are basically a set of standards that ethically conscious investors use to screen potential investments. By guaranteeing green compute, India can attract significant international capital that is specifically looking for sustainable technology solutions, differentiating itself from other potential AI hubs.
Okay, so we have this virtuous circle. Cheap green energy enables cost-effective AI, and building a green AI sector attracts investment. Now, let's get deeper into the mechanics. You mentioned the phrase AI learns from sunlight. Explain how this proposed trillion-watt brain ecosystem is supposed to function.
Right, the trillion-watt brain concept describes a system designed to be self-learning and dynamically adaptive. It works in two directions.
Direction one.
Direction one is AI optimizing the energy system. Sophisticated AI models are used to do things like forecast energy demand across the hub with incredible accuracy, minutes or hours ahead. They manage the complex interplay between solar generation, wind generation, battery charge-discharge cycles, and the data center's power consumption.
So managing the grid more intelligently?
Yes, predicting potential faults in the energy infrastructure before they cause outages, and ensuring the most efficient distribution of power to minimize waste. This active AI management can drastically reduce system losses and improve reliability.
Okay, that's AI helping the energy side. What's the other direction?
The other direction is the physical energy infrastructure, directly enabling and fueling the AI development. The abundant, clean power from solar, wind, and potentially green hydrogen provides the massive, sustainable, and cost-effective electricity needed for the really demanding tasks, like training the next generation of large language models, LLMs, or complex scientific foundation models. These tasks require huge, stable blocks of power for extended periods.
And the trillion-watt brain part comes from how these two sides interact dynamically.
Exactly. It's not static. The key is that the data center workloads can dynamically adjust based on the real-time availability of renewable energy. For example, if the coastal wind farms are hitting peak generation overnight, the AI orchestrator can automatically ramp up non-urgent, computationally intensive tasks, maybe model retraining or large data analysis jobs, to take advantage of that cheap, abundant power.
And conversely, if solar input dips unexpectedly due to cloud cover,
Then the local battery systems kick in instantly to stabilize the grid, while the AI controller might intelligently throttle less critical background processing tasks within the data center to conserve power until generation picks back up. It's about extremely sophisticated real-time algorithmic management of power demand and supply at a massive scale.
that level of dynamic optimization, that tight feedback loop, that sounds like what would make it a genuinely world-leading prototype, if they can pull it off.
It is. It's aiming for a closed-loop ecosystem where the digital intelligence is constantly learning from the physical environment, optimizing the energy infrastructure, which in turn provides cleaner, cheaper power back to fuel the growth of that intelligence. The synergy isn't just a feature. It's foundational to the entire economic vision, the $40 trillion target we'll get to later.
Okay, we've covered the physical infrastructure, the energy, the scale, but building all this hardware, this trillion-watt brain, is only one part of the equation, isn't it? What about the data itself? What about the rules governing this intelligence?
Absolutely crucial. We need to pivot now from megawatts and petaflops to the, let's say, the moral, ethical, and legal framework. The sources we reviewed are incredibly clear on this. Compute sovereignty, having the machines, must be matched by data sovereignty and a strong commitment to an ethical core, which they term clean data.
Right. The headline commitment seems to be that all data will be kept in the country. That sounds straightforward, but in the age of global cloud giants and international data flows, what does data sovereignty practically mean? Especially when you have a $15 billion partnership with Google Cloud involved right at the heart of this Visag project. Doesn't bringing in a major foreign cloud provider inherently complicate that sovereignty promise?
That is precisely the tension, and the sources definitely anticipate this question, this potential criticism. The underlying strategy seems to be built on that analogy we discussed earlier. Data is like crude oil.
It needs to be refined domestically.
Exactly. It needs to be processed and refined within India's borders before its higher value. The insights, the intelligence derived from it, can be potentially exported or used. So the framework seems to allow for foreign investment in and even ownership of the physical hardware, the data centers themselves, like the Google partnership. However, the critical condition is that the operational control, the policy frameworks governing the data's use, and crucially, the ultimate right to access, govern, and potentially monetize the insights derived from that data must remain firmly within India's national jurisdiction.
That sounds like it requires some very carefully crafted legal and regulatory frameworks. If the servers are physically in India, but the core algorithms processing the data are developed, owned, and updated by a foreign entity like Google, where does sovereignty truly lie? Is location enough?
That's the core debate. The sources argue that genuine sovereignty requires more than just physical location. It necessitates deep integration of domestic talent, Indian engineers, data scientists, policy experts into the operation and oversight. And it demands very clear governance policies regarding algorithmic transparency, access rights, and data usage permissions. It's not just about where the data sits. It's about who controls the entire processing chain.
And this commitment to domestic control and oversight seems to be directly linked to this concept of clean data.
Yes, they flow together.
So let's define clean data. It's an evocative term, but what does it mean in practice? How would it be implemented or regulated? It's definitely not about censorship, is it?
No, the sources are very clear. It's not censorship. Instead, clean data focuses on three pillars:
Yeah.
truth, transparency, and trust.
Okay, what does that mean operationally?
Operationally, it translates into a set of principles that data must adhere to. First, it must be collected with explicit, informed consent from individuals. No hidden or predatory data harvesting. Second, as we discussed, it must be stored primarily within India's sovereign boundaries,
Yeah.
especially sensitive personal or national data.
And third,
Third, and this is perhaps the most challenging part, it must be processed by algorithms that are, as much as possible, auditable, fair, and explainable. The logic shouldn't be hidden inside an impenetrable black box, especially for AI systems impacting people's lives. The ultimate goal here is to actively combat what the sources call cognitive pollution.
cognitive pollution, that's pollution of the mind, essentially.
Yes, that invisible smog of misinformation, disinformation, deep fakes, and manipulative algorithms that can cloud human judgment, erode trust, and potentially destabilize democratic processes. Clean data is positioned as the antidote.
So if a tech company, whether domestic or international, wants to operate within this envisioned Indian AI ecosystem, what kind of mechanisms are being discussed to actually enforce this clean data standard? How do you audit an algorithm for fairness or demand explainability?
Well, the push seems to be towards mandating regular independent bias audits for large-scale AI models being trained or deployed within India. These audits would specifically check how the model performs across India's diverse demographic groups, languages, and social contexts to identify and mitigate unfair biases.
Okay, bias audits. What else?
Furthermore, there's discussion around developing regulatory frameworks that would require algorithmic explainability, particularly for any AI system used in critical areas like public services, healthcare, education, the justice system, or managing essential infrastructure. Citizens need to understand, or at least have the ability to challenge decisions made about them by machines.
And this whole ethical framework has a name.
It's often referred to aspirationally as achieving digital Dharma. The idea borrows from Indian philosophy. Dharma implies a sense of duty, righteousness, and cosmic order. So digital Dharma is the principle that technology must be developed and deployed in a way that serves life, enhances human potential, and aligns with ethical principles rather than simply dominating or displacing humanity for profit or control.
That's a very ambitious ethical overlay onto a massive tech project, but this ambition must create friction, right? Let's talk about the trade-offs. The original material mentioned the tension between data localization and global interoperability, but maybe we can flesh that out more. What are the specific downsides or difficulties when you try to enforce a strict keep data within the country policy?
That's a major friction point, absolutely. The
Mhm.
primary concern often raised is that strict data localization policies can potentially stifle innovation, especially collaborative, cutting-edge research. Many breakthroughs in AI, for instance, rely on researchers sharing and accessing massive, diverse data sets from around the world.
So, locking data down geographically could isolate Indian researchers.
It could. It might prevent them from participating fully in global research consortia or accessing the diverse global data needed to train truly robust and generalized models. There's a risk of creating a sort of digital island. Furthermore, it complicates things immensely for multinational corporations operating in India. Cross-border data flows are often essential for their internal operations, supply chains, customer service, etc. Making those flows difficult or illegal can be a significant barrier to investment and doing business.
So, India needs to find a balance.
Exactly, it's a tightrope walk. They need to find a regulatory middle ground. Perhaps mandating strict localization only for highly sensitive personal data, critical national security data, or public sector data, while allowing for more flexible, secure, potentially anonymized or aggregated data sharing for commercial purposes or non-sensitive global research collaborations. Getting that balance right is key.
This complexity really highlights why the sources introduced this novel metric for measuring national strength moving beyond just GDP, gross domestic product, to something they call GDP, gross domestic data power. That's a fascinating concept. How would GDP actually be measured? It's not just about volume of data, is it?
No, it's much more nuanced than just counting petabytes. GDP is envisioned as a composite index, a framework to measure a nation's strength not just by the economic value of its digital output, but by its capacity to generate, store, process, govern, and ethically utilize its own data wealth. It's a measure of sovereign control and the quality of the data ecosystem, not just quantity or raw economic activity derived from it.
So what factors would go into calculating a GDP score?
It would likely involve assessing several things. First, the installed compute capacity may be measured in teraflops or petaflops per capita, indicating the raw processing power available domestically. Second, the percentage of data storage infrastructure that is domestically owned or controlled. Third, the regulatory maturity, how robust are the data protection laws. This could be measured using indices similar to Europe's GDPR compliance scores.
And the ethical dimension.
Yes, critically and ethical governance score. This could be derived from factors like the implementation of those bias audits we discussed, the transparency requirements for algorithms, the strength of citizen data rights, and mechanisms for redress.
So under this GDP model, a country could have a very high traditional GDP, maybe driven by foreign tech platforms operating within its borders, but still have a relatively low GDP if most of its critical data is actually stored offshore, processed by foreign algorithms, or if its data governance policies are weak and don't protect citizens.
Precisely. It forces policymakers and citizens to look beyond just the surface economic activity and focus on the underlying strategic infrastructure of data control, data quality, and ethical usage. The whole GDP framework shifts the national conversation from merely consuming technology or generating revenue from it to ensuring that technology is building sustainable, sovereign national capability and resilience for the long term.
Okay, so we have this massive domestic investment in green compute infrastructure in Visag, coupled with this ambitious framework for data sovereignty and ethical governance under the banner of GDP and clean data. How does all this play out on the global stage? Where does this position India geopolitically?
This is where the strategy moves explicitly into geopolitics. The sources state very clearly that India, through this combined approach, is actively seeking to carve out a distinct third path, a doctrine they call digital non-alignment, navigating the intensifying, you might say, global AI Cold War between the United States and China.
Digital non-alignment. That term obviously echoes India's historical foreign policy stance during the original Cold War.
Exactly. India was a founder of the non-aligned movement, consciously refusing to be drawn fully into either the US-led capitalist bloc or the Soviet-led communist bloc. This digital non-alignment is presented as a modern application of that same core principle, seeking strategic autonomy in a world increasingly dominated by two competing digital superpowers.
So let's clearly lay out the two dominant models that India, according to the strategy, is trying to consciously avoid being forced to choose between.
Okay. The first model is broadly the U.S. model. This is characterized as being fundamentally corporate-driven. It relies heavily on vast amounts of private venture capital, is dominated by a few very large big tech companies, and tends to prioritize rapid innovation, consumer platforms, and shareholder value sometimes, the critique goes, prioritizing speed and profit over deeper ethical considerations or societal impact.
Okay, the corporate-led Silicon Valley model. What's the second pole?
The second is the Chinese model. This is characterized as being state-driven and highly centralized. It involves deep integration between tech companies and the state apparatus, often leverages technology for widespread surveillance and social credit systems, and fundamentally views data as a primary tool for state control, social management, and projecting national power.
And India's argument is that neither of these models fully fits its own values or strategic interests.
That's the core assertion. India's ethos, rooted in its democratic traditions, its incredible internal diversity, its constitutional framework emphasizing individual rights, and open debate, demands a different kind of digital ecosystem. One that aims to be, as the sources put it, open but sovereign, innovative but ethical.
So the bottom line is quite stark. India intends to neither surrender its data to Silicon Valley nor its algorithms to Beijing.
That's the declared goal. But, and this is critical, a doctrine like digital non-alignment needs more than just words or political declarations to be credible. A doctrine without the underlying infrastructure to support it is, as one source evocatively put it, just poetry.
Meaning you need the hard power, the compute, the energy, the data centers to actually be autonomous, not just declare it.
Precisely. This strategic autonomy isn't just a political stance. It has to be secured through concrete, integrated capabilities. The sources identify four key pillars that underpin this digital non-alignment, pillars that go beyond just diplomacy.
Okay, let's detail these pillars. What's the hard infrastructure required for genuine digital non-alignment?
Pillar number one is compute sovereignty. This means building and ideally controlling hyperscale data centers domestically. It's about minimizing reliance on foreign cloud providers for core government functions, critical infrastructure management, and the processing of sensitive national data. So even while partnering with Google initially for their expertise and capital.
The long-term strategy has to be building up India's own indigenous cloud capabilities and potentially even hardware design and manufacturing.
That appears to be the underlying ambition. Achieve technological self-reliance in the core compute stack over time. Pillar two is energy sovereignty,
which we've discussed extensively, running the AI on clean, domestically produced power.
Yes, and this is crucial for autonomy. Relying on imported fossil fuels makes you vulnerable to global price shocks and geopolitical manipulation. Using domestic solar, wind, perhaps green hydrogen insulates the digital economy from that volatility and directly links national security to sustainable energy policy. It's a powerful synergy.
Okay, compute and energy sovereignty, pillar 3.
Pillar 3 is data sovereignty, which we've also dug into. It's about ensuring that Indian data, particularly sensitive data, is stored, processed, governed, and ultimately benefits the nation from within its own jurisdiction, backed by strong laws like the proposed data protection bills and the principles of clean data.
Makes sense. And the final pillar.
Pillar 4 is perhaps the most crucial for long-term success: talent sovereignty. This involves aggressively investing in developing a deep pool of indigenous talent. World-class computer scientists, AI researchers, but also AI ethicists, digital policy experts, regulators, and engineers who can design, build, audit, and govern India's own technology stack. True autonomy isn't just owning the machines, it's having the human capital to master them.
So it's a holistic approach: hardware, energy, data rules, and people all working together to create genuine strategic independence.
Exactly. And this comprehensive approach is why India believes it can position itself not just as non-aligned, but potentially as the preferred ethical hub for global AI development.
How so? What's the argument there?
The argument is that while the US and China might be racing to build the fastest AI or the largest AI models, India has a unique opportunity to focus on building the fairest and most trustworthy AI systems.
Because of its specific characteristics.
Yes. Its sheer scale and unparalleled diversity, linguistic, cultural, socio-economic, make it the ultimate real-world laboratory for developing and testing AI for fairness, robustness, and inclusivity. If you can build an AI model that works fairly and equitably across India's 22 official languages, hundreds of dialects, and diverse population groups,
Then you've demonstrated a level of algorithmic pluralism and bias mitigation that's potentially world-leading.
precisely. The argument follows that in an age where trust in technology is increasingly fragile, demonstrating that commitment to fairness, transparency, and ethical governance, backed by its democratic structure and constitutional safeguards, could become India's core competitive advantage. Trust itself becomes the rarest, most valuable commodity in the AI era.
So they're trying to turn their complex societal fabric and democratic checks and balances from a potential challenge into a strategic asset for attracting investment and talent that specifically prioritizes responsible AI development.
That seems to be the strategic calculation. Leveraging its unique democratic DNA to attract the kind of global partners and investments that are becoming increasingly wary of the more opaque, centralized, or purely profit-driven models seen elsewhere.
Okay, this is a massive domestic transformation strategy with huge geopolitical implications. But the vision described in the sources doesn't stop at India's borders, does it? It seems to extend outwards, particularly towards the global south.
No, it definitely doesn't stop at the borders.
Yeah.
A major component of this entire strategy is positioning India as a leader and partner for the developing world, the global south. And this involves pioneering a new form of foreign policy, which the sources term compute diplomacy.
Compute diplomacy, what does that entail? How is it different from traditional foreign aid or diplomacy?
It represents a fundamental shift. Instead of the traditional models of aid exporting food, offering loans, sometimes military equipment, compute diplomacy focuses on exporting the foundational tools for digital empowerment. India seeks to export compute and code.
Meaning the infrastructure and the software for digital self-reliance.
Exactly. Providing partner nations in Africa, Southeast Asia, Latin America with the blueprints, the technology, and perhaps the financing models to build their own sovereign digital infrastructure based on the principles India is developing domestically, particularly the link between low-cost renewables and AI.
So this changes the dynamic. It moves away from the old model where developing nations might become dependent on aid or locked into technology ecosystems controlled from the north.
And moves towards a model of interdependence, potentially, creating sovereign digital partners who have shared interests in building an alternative, more equitable global digital order. It's about fostering self-reliance, not dependency, ideally on more equal terms.
What would this exportable model look like in practice? What specific things could India offer?
The sources suggest several concrete elements. First, exporting the designs and potentially components for low-cost, renewable-powered AI infrastructure, things like blueprints for modular data centers optimized for tropical climates, efficient battery management systems, and ruggedized edge AI hardware suitable for deployment in areas with limited connectivity or power.
So hardware and infrastructure know-how. What about software and applications?
Yes. Second, providing access to AI-powered tools and platforms specifically trained on relevant data and tailored for the unique needs of developing economies. Think AI models for optimizing crop yields based on local weather patterns, AI-driven diagnostic tools for common diseases in regions with few doctors, or personalized adaptive learning platforms for education delivered via mobile devices.
Tailored solutions, not just generic ones.
Exactly. And third, a really ambitious idea, actively working to build genuine South-South data corridors.
Okay, what does that mean? Like digital trade routes between developing nations? Essentially, yes. It's envisioned as a digital equivalent of the non-aligned movement's historical efforts to create alternative economic and political networks, bypassing the dominant east-west axis. These corridors would involve building direct fiber optic links, establishing shared data governance protocols, and potentially creating shared cloud infrastructure, connecting key hubs across the global south. Maybe linking Nairobi to Jakarta or Sao Paulo to Lagos, perhaps routed via India.
And the strategic goal of these corridors.
The goal is to ensure that the data generated within the Global South is increasingly processed, analyzed, and monetized within the Global South, creating local economic value and fostering indigenous innovation, rather than having that value primarily extracted by established big tech players headquartered in the Global North. It's about building a counter-narrative and a counter-infrastructure to the existing digital power structures.
This global outreach, this compute diplomacy, seems to tie everything together. It connects the domestic strategy in Visag with the geopolitical positioning and the economic ambitions. It does. It brings us to the final strategic formula presented in the sources, which encapsulates this entire vision. They call it the trillion-dollar trinity.
The trillion-dollar trinity. Okay, break that down for us. What are the three elements?
The trinity synthesizes the whole strategy into three core interdependent engines. Engine one is artificial intelligence, AI itself, serving as India's primary cognitive engine for innovation, efficiency, and problem-solving. Engine 2 is green energy, providing the sustainable, low-cost, and sovereign power source needed to fuel that AI engine reliably and ethically.
AI is the brain, green energy as the power source. What's the third element?
Engine 3 is Global South alliances. These alliances serve as a crucial moral, strategic, and geopolitical multiplier. They provide a vast potential market for India's exported digital services and infrastructure. They reinforce a digital non-alignment stance by building a coalition of like-minded nations. And they position India not just as a tech power, but as a potential moral leader, championing a more equitable digital future for the developing world.
And the trillion-dollar part of the Trinity name refers to the potential economic outcome if the strategy succeeds.
Yes, the economic projections linked to the successful execution of this trinity are enormous. Some analysts cited in the sources suggest that this comprehensive structural transformation, successfully fusing AI, clean energy, and global partnerships, could be the engine that drives the Indian economy towards becoming a $40 trillion economy by around 2045.
$40 trillion. That's a staggering number. What does that imply for India's global standing?
Well, achieving that scale, especially through this particular strategy, would fundamentally shift India's geopolitical categorization. It wouldn't just be a leader of the Global South, it would arguably become a definitive global center in its own right. It could position India as the world's first truly green compute state, a major economy whose core competitive advantage is built on clean energy powering sovereign AI.
Which would presumably attract even more global investment from entities seeking stable, ethical, and sustainable jurisdictions for their advanced computing needs, data storage, and AI development.
That's the anticipated flywheel effect. Success breeds more success and investment. And in this vision, India isn't aiming to be just another superpower in the traditional mold. The aspiration articulated is for India to become a superpartner.
A superpartner, what's the distinction?
The idea is to be a nation that actively demonstrates how to merge deep technological innovation with profound social inclusion, how to balance the drive for economic growth, profit, with a clear sense of ethical responsibility, purpose. It's about building partnerships based on mutual benefit and digital empowerment.
Which ties back to that concept of digital Dharma.
Exactly. The moral foundation is presented as essential to the entire edifice. The ambition isn't just to build powerful intelligence, but to build intelligence with soul, guided by ethical principles. By championing this green, sovereign, ethical, non-aligned path, India seeks to redefine global power itself, moving away from zero-sum competition and domination towards a model of exporting digital self-reliance, not imposing digital dependency or debt.
It's an incredibly ambitious, multi-layered strategy we've unpacked today.
Truly nation-building in scope.
Okay, let's try to summarize the key takeaways from this deep dive. We started with the fundamental paradigm shift. The idea that compute power is replacing oil as the key strategic resource of the 21st century.
Right. Then we looked at the concrete manifestation of this in India,
Hmm.
the massive investment in Vizag, aiming to create a green Silicon Valley by fusing AI development with gigawatt-scale clean energy infrastructure, solar, wind, batteries, all dynamically managed.
We explored the critical importance of sovereignty, moving beyond just compute to data sovereignty, introducing concepts like GDP, gross domestic data power, as a new metric, and the ethical framework of clean data and digital Dharma to combat cognitive pollution and build trust.
And then we place this domestic strategy within the global context, India's pursuit of digital non-alignment, as a third way between the U.S. and Chinese models, built on the four pillars of compute, energy, data, and talent sovereignty.
Finally, we saw how this vision extends outwards through compute diplomacy, aiming to lead and partner with the global south, synthesized in the trillion-dollar trinity of AI, green energy, and global alliances, with the ultimate goal of becoming a $40 trillion green compute state and a global super partner.
It's a comprehensive long-term bet on fusing technology with ethics and sustainability.
So we've explored how India is betting, quite literally, on sunlight and silicon to reshape its destiny and potentially influence the global digital order.
The core argument running through all the material is that the next great global competition, the one that will truly determine leadership of the 21st century, might not ultimately be won just by the nation that builds the fastest processors or the biggest AI models,
But rather
by the nation or group of nations that successfully builds the fairest systems. Systems built on verifiable trust, transparency, ethical governance, and genuine inclusivity. These are increasingly being viewed not as soft values, but as hard strategic assets.
Which leads us perfectly to the final provocative thought we want to leave you, our listener, with today.
The sources we looked at consistently argue that a nation's true, enduring wealth isn't just its GDP figures. It's measured by what it manages to preserve and nurture its environment, the integrity and truthfulness of its information ecosystem, and the fundamental dignity and potential of its people.
So if we accept that premise, even just for a moment,
The question for you to consider as we witness this global race for AI dominance is this. When compute is the new oil, can national progress, can true strength ultimately be measured not just in profit margins and processing speed, but in participation, fairness, and trust?